Hello and welcome. I'm Abdullah. Today I'll be explaining my ROS2 based robotic arm visualization project. This project consists of two main components, a 2D joint visualizer and a 3D arm visualizer. So let me just go through my code. So under my workspace, let me just open it in VS Code. So here you can see under my workspace there is an arm visualizer package, and the package has two specific nodes. One is the joint visualizer and another is the 3D visualizer. So in the joint visualizer node, this is our first node. In this node we are using ROS to tkinter and matplotlib to create a 2D visualization of the robot arm. This node subscribes, you can see that this node subscribes to a topic called joint angles, where it listens for updates on the joint positions. Again, it also publishes, you can see it is also acting as a publisher. It also publishes its updated joint angle by taking input from the sliders that we will later show in the GUI. So in this joint visualizer node, we have built up a graphical user interface using the tkinter library of Python. The GUI or the graphical user interface has basically four parts. Uh, there are four sliders. You can see we have a slider, and the four sliders, each of them are a base top view slider, shoulder slider, elbow slider, and wrist slider. By moving this slider, we can adjust the angle, and the angles can be from 180 to minus 180 degrees. Here you can see the range. Here is some customizations like the colors. So I have customized the GUI as per my preferences. So this is all about this. There are different methods like updating the plot with the new angles. As soon as I change the angle values in the sliders of the GUI, the plot in the GUI is also updated. So here for plotting, I use the matplotlib library. That's all about my joint visualization node. Next is the 3D arm visualization node. So we have the 3D arm visualizer. This is a separate roster node that provides a 3D representation of the robotic arm using matplotlib's 3D plotting tools. This node subscribes to the same joint angle. You can see it's subscribing to the same joint angle topic and updates the visualization in real time. Moreover, it also uses forward kinematics. You can see we're using forward kinematics to calculate the accurate positions of the joints. For example, if I move the shoulder joint, then the respective position of the elbow and wrist also changes. This is basically forward kinematics. Okay, now I will demonstrate the nodes one by one. So at first I will run the joint visualizer node, and let's see how the GUI works. And I will also run the 3D visualizer at a time. So let's run it, and the 3D visualizer. So here I have the two nodes side by side. So if I change the base angle, you can see the base angle of the arm is changing. If I see in the 3D view, you can see exactly the same thing occurs in the 3D view. If I change the shoulder angle, you can see we can demonstrate, or we can see it in the front view. If I change the elbow angles, you can see all the elbow angle changes in both the views, in the 3D and the front. If I change the wrist angle, you can see the wrist angle is also changed. Moreover, I can change I can set the angles from 180 to minus 180. It is true for elbow, shoulder, or base. In all the cases, I can set the values from 80 to 180 to minus 180 degrees. So this is how my GUI works. In the GUI, I have a 2D visualization of the top view and the front view, and in second I have a matplotlib representation of the 3D arm. So I hope you understand how my code works. Thank you.